In the midst of the Second World War, on January 8, 1942, a child destined to reshape our understanding of the cosmos was born in Oxford, England. His name was Stephen William Hawking. He entered a world defined by conflict, yet his life would be dedicated to unraveling the deepest, most universal mysteries. His father, a research biologist, had moved the family to Oxford to seek a safer environment away from the bombing raids in London. Young Stephen's early education was at St. Albans School, where he was a good, though not exceptional, student type. His innate curiosity for how things worked was already apparent, as he was known to disassemble clocks and radios. He and his friends created a computer from recycled parts to solve rudimentary mathematical equations. In 1959, at the age of 17, he won a scholarship to study physics at University College, Oxford. He found the undergraduate work at Oxford to be, in his own words, ridiculously easy. He dedicated more time to the university's boat club, becoming a coxswain for the rowing team. After obtaining his bachelor's degree, he moved to Trinity Hall, Cambridge in 1962 to begin his graduate work in cosmology. It was at Cambridge that his life took a dramatic and unforeseen turn. He began to experience increasing clumsiness, including a fall on the ice skating rink. At the age of 21, he was diagnosed with amyotrophic lateral sclerosis (ALS), a form of motor neuron disease. Doctors gave him a life expectancy of only 2 years. The diagnosis plunged him into a deep depression. He saw no point in continuing his studies, as he did not expect to live long enough to finish his PhD. However, the progression of the disease was slower than anticipated. His relationship with Jane Wilde, whom he had met shortly before his diagnosis, gave him a new reason to live. They were married in 1965, a testament to their shared determination. With renewed purpose, Hawking returned to his work with vigor. He was galvanized by the work of Roger Penrose on the concept of a space-time singularity at the center of a black hole. Hawking applied the same thinking to the universe as a whole. Together, he and Penrose demonstrated that if general relativity is correct, the universe must have begun as a singularity. This provided powerful theoretical support for the Big Bang theory. By this time, Hawking's physical condition had worsened, and he was using crutches and was no longer able to write easily. He began developing compensatory mental methods, visualizing complex equations and shapes in his mind. His focus then shifted to the enigmatic objects known as black holes. A key principle was the no-hair theorem, which states that black holes can be characterized by only 3 properties: mass, charge, and angular momentum. All other information, or hair, about the matter that formed it would be lost. This led Hawking to a profound and startling contradiction. Quantum mechanics dictates that information can never be truly destroyed. But if a black hole swallows information and then evaporates, the information is lost forever. While investigating this paradox, Hawking made his most famous discovery. He realized that black holes are not entirely black. Due to quantum effects near the event horizon, they should glow with thermal radiation. This phenomenon became known as Hawking radiation. The discovery was revolutionary, linking general relativity, quantum mechanics, and thermodynamics for the first time. It implied that black holes have a temperature and will eventually evaporate over immense timescales. The initial reaction from the physics community was one of skepticism. But the mathematical foundation of his theory was solid, and it eventually became widely accepted. This work cemented Hawking's reputation as a leading physicist of his generation. By the late 1970s, His physical condition had declined to the point where he could no longer speak without great difficulty. His students had to help translate his mumbled speech. In 1985, during a trip to CERN, he contracted severe pneumonia. The illness was life-threatening, and doctors performed a tracheotomy to save him. The operation saved his life, but took away his remaining ability to speak. For a time, he could only communicate by raising his eyebrows to choose letters on a spelling card. The world was at risk of losing access to one of its greatest minds. A California computer programmer named Walt Woltos developed a program called Equalizer for him. This system allowed him to select words and commands with small movements of his hand or cheek. A speech synthesizer, which he would become famous for, gave him his iconic computerized voice. Chose a voice with an American accent, and he kept it for the rest of his life. Freed from the constraints of his body, he embarked on a new project, writing a book for the general public. In 1988, he published A Brief History of Time, From the Big Bang to Black Holes. The book was an unprecedented success, selling millions of copies worldwide. It brought abstract cosmological concepts to a mass audience in an accessible way. Hawking became an international celebrity, a symbol of the power of the human mind over physical adversity. He continued his research, focusing on the information loss paradox and the nature of space-time. He proposed that information was not truly lost, but was stored on the event horizon in some form. His work on the Hartle-Hawking state proposed a boundary condition for the universe. It suggested that the universe has no initial boundary in time, no moment of creation. As he famously put it, "What I have done is to show that it is possible for the way the universe began to be determined by the laws of science." Throughout his life, he remained a public figure, advocating for science and disability awareness. He made guest appearances on shows like The Simpsons and Star Trek, The Next Generation. His life story was told in the acclaimed 2014 film, The Theory of Everything. He continued to refine his theories, even in his final years. His final paper, submitted shortly before his death, dealt with the information paradox and the concept of soft hair on black holes. Stephen Hawking passed away on March 14, 2018, at the age of 76. He had lived more than 50 years longer than doctors had predicted. His death occurred on Pi Day, the same date as Albert Einstein's birth. His ashes were interred in Westminster Abbey, between the graves of Isaac Newton and Charles Darwin. Stephen Hawking's legacy is twofold. He fundamentally changed our understanding of gravity and the cosmos, and he became a beacon of hope, proving that the human spirit is limitless. His journey from a young student with a terminal diagnosis to a titan of science continues to inspire millions. He taught us that black holes are not eternal prisons, and that the universe's secrets are not beyond our reach. He urged us to look up at the stars and not down at our feet. Try to make sense of what we see, and wonder about what makes the universe exist. To be curious. His physical voice was synthesized, but his intellectual voice echoed across the cosmos. The boy who took apart clocks eventually took apart the universe to see how it worked. And in doing so, he showed us what it means to be truly human. The theory of Hawking radiation remains a cornerstone of theoretical physics. It poses challenges that physicists are still working to solve today. The information paradox, which he ignited, is one of the most profound puzzles in science. His life demonstrated that disability does not have to be a barrier to great achievement. He embraced technology not as a replacement, but as an extension of himself. His wheelchair and voice synthesizer became inseparable from his public persona. He traveled the world, from Antarctica to Easter Island, to deliver lectures. He even experienced zero gravity aboard a specially modified aircraft. This was a preparatory step for his planned journey into space. He believed that the long-term future of the human race must be in space. He warned about the potential risks of artificial intelligence. He also spoke about the importance of tackling climate change. His scientific bets with other physicists, like Kip Thorne and John Prescott, were famous. He conceded his bet on the information paradox in 2004, admitting black holes do not destroy information. His work was not just about abstract concepts. It was about the very nature of existence. He pushed the boundaries of knowledge, forcing us to confront the limits of our understanding. His theories painted a picture of a universe that was more bizarre and wonderful than ever imagined. He was a scientist, a communicator, a fighter, and an inspiration. The universe, he believed, was a puzzle, and he dedicated his life to finding the pieces. His intellectual journey began with a desire to understand the universe's beginning. He ended by contemplating its ultimate fate. He showed that the largest questions could be tackled by the power of pure thought. His office at Cambridge was filled with books, equations, and a sense of boundless curiosity. He was the Lucasian Professor of Mathematics at Cambridge, a chair once held by Isaac Newton. This position placed him at the heart of the British scientific establishment. Despite his fame, he remained focused on his research and his students. He possessed a wicked sense of humor, often hidden behind his synthesized voice. He once threw a party for time travelers, but only announced it after it had happened. No one came, which he claimed was experimental proof that time travel to the past is not possible. His ideas were often grand, cosmic, and mind-bending. He contemplated the existence of multiple universes, or a multiverse. His work suggested that our universe might be just one of many. He was a theoretical physicist, meaning his laboratory was his own mind. The tools he used were mathematics and imagination. He sought a single, elegant equation that could explain the entire universe. This quest for a theory of everything was a driving force in his career. He acknowledged that such a theory might not be possible, but the search was paramount. His first book for children, George's Secret Key to the Universe, made cosmology accessible to the young. He co-wrote the series with his daughter, Lucy Hawking. He believed in the importance of inspiring the next generation of scientists. His popular lectures were legendary, filled with wit and profound insights. He had a unique ability to explain the most complex ideas in simple, elegant terms. He was a bridge between the arcane world of theoretical physics and the public's imagination. His life was a study in contrasts, a paralyzed body with a mind that roamed the cosmos freely. He explored the beginning of time and the fate of black holes. He never won a Nobel Prize, as his theories were difficult to prove experimentally. However, the discovery of gravitational waves has opened new windows to test his predictions. Future observations of black holes may yet provide the evidence needed. His influence extends far beyond the pages of scientific journals. He's a permanent fixture in our shared cultural understanding of science. The questions he asked are the questions that humanity has always asked. Where did we come from? Where are we going? Are we alone? Stephen Hawking's life and work provided not all the answers, but a clearer path to finding them. His story is a testament to the indomitable curiosity that defines the best of humanity.